So hello, and today in this episode we're gonna talk with Ritchie Vink and Marc Garcia, and we're gonna talk about data frames in general. So Ritchie is the author of Polars, and Marc is core developer of pandas. So I'm gonna start with an interesting question. So what do you think will happen in the data frame like landscape in like 5 years, let's say?
Is it for me? um, I'm gonna be opportunistic here, but I hope that there will not be a monopoly on the data frames as much anymore as pandas. I think it will be more. Um, it will be similar to how it is in R. There are more data frame implementations, and people um, use some use dplyr, some use data table. I think it will be more like that. But also there will be more interoperability with new data frame or every data frame implementation. I think with most converging to Arrow, interop will be free, and you can and also plotting libraries can be agnostic of which data frame implementation they use. So I think there will be more. Um, it will be more generic, like it can be any implementation, and there will be more crossover, I think, with also the data frame consortium itself. I also think that PyArrow itself is doing some compute. Yeah, there will be. It will be more. It will be more rich, I would say.
Yeah, I do agree on that. I think the having a bigger ecosystem of libraries, I think it's a very positive thing. I think the data frame space is pretty big. I personally see two very different use cases, and probably there are more. Like one data analyst working in front of a Jupyter notebook is very different from someone building a pipeline on a Git repo and running that every night at the speed. And I think Pandas, being the monopoly, has basically tried to fix the problems for the whole community. I think Polars, for example, is doing a much better job at the software engineering part. I think adds a lot of value. It's not that it doesn't work for the others, and maybe even better than Pandas. I don't have an opinion on that, but I think Pandas is still doing pretty good. If you have like a Jupyter notebook and you execute your code at every cell, like some of the things that Polar brings, like the query optimizer, are not going to be as useful. I mean, you're going to lose that, and Pandas is competing much stronger with Polars in terms of speed and those things. So I think having options is good because we have different users, and I think the whole data frame user community is pretty big. And I also personally think that the data frame, what we have, the idea of data frame Pandas was built like as a monster. It's pretty big like library, and we're suffering every day from that. I hope that, I don't know if it's how I see the community in 5 years, but that's at least my hope, that we'll see like more modularization, like having like that you are not choosing between Polars and data frame, but you're using like, okay, this API and this API, then you have options for the data representation, whether you want data in disk in Parquet, or you want data in memory in Arrow, or you want the operations running from this implementation or the other. I think that's like having like a bit like Linux is designed, that you don't have just like a single operating system. You just choose the pieces that work for you. I think like that would be a very better position in terms of maintaining and options for the user.
Yeah, and then someone comes in and says, "I'm using Arch," right? No.
Everything from scratch. Yeah.
Yeah, but on that end, right? So like you were talking about interoperability, of different data frame libraries and whatnot, and then like what I noticed, like DuckDB comes in, right, and it's kind of stealing all the thunder, right? Like no one is talking about, like is it actually the end of the big data, right? We can do everything, somewhere on smaller machines, smaller scales and whatnot. And the thing what DuckDB brings is actually, the SQL part, right? Which everyone is familiar. Talking about data frame libraries, right? Not all of them has like native SQL capabilities. Polars has it. I checked. Spark has it. Like for Pandas, there are like other libraries which have wrappers around it. So what would you say, is like what will be the end goal like for data frame APIs versus SQL APIs?
I'm gonna answer this one as only for the Polar's head. I don't know how I would answer it for more generic for the data frame landscape itself. But for Polars, the SQL front end makes a lot of sense. We are basically just a query engine, and SQL is a very natural front end on top. And we make huge leaps with that this year. The amount of SQL support we have increases every week, and I think we can be full SQL compliant end of this year, maybe. And this always made sense for Polars. So Polars is a super young project. We haven't even touched the 3 years now. I believe it's 2 years younger than DuckDB. So we're already super far, I would say. And I think the SQL makes a lot of sense for Polars, but I also think the dataframe API makes a lot of sense. The reason why I chose for dataframe API is because it fits very natural in software engineering. You can push it to, you can pass it to as an argument to a, you can really see it as a data structure, which a SQL query is more of a linear thing. I write this query and I execute it from beginning to end, and then I'm done. And I would say in data frames you can be more iterative and exploratory, but also more, it opens up a lot of extra software engineering capabilities, which SQL is only the API and not per se the data structure.
Yeah, I fully agree on that. I think personally I found SQL much better when you have small queries. If you are just gonna write a select with maybe a couple of joins or one join and few calculations, it's pretty good. If you have a whole pipeline implementing in SQL, I'm sure how many people suffered from this, like monster SQL, like creating views that then are used and querying when you have one part of your join, when in your from you have like several subqueries and things like that. Yeah, that's something that I don't think anyone is happy to deal with. While a data frame like API is much better. But I think like every user have different needs. I think we'll have this hopefully decoupling from what's the API and what's the execution. For example, pandas doesn't have any SQL. There are no plans, and I don't think it makes sense. Like maybe in 5 years' time, pandas change enough so it's able. But for example, pandas is used by Dask or by Modin, and they have their query engine, and they do the operations in pandas. So it's kind of part of this, and I think this decoupling needs to happen more, because you really don't want to just get a user write SQL to end up like executing like pandas via its API. I mean, that's pretty much a monster that you don't want to deal with. Now the community is moving. We have Substrate, so you can create these plans in Substrate, and then you can execute like. So we have an API on the, let's say, from the user API to the execution. We have this standard like API, the standard definition that you can share query plans, that you can share the code in a machine way to say. I think like Pandas API is surely not designed for that, and hopefully then in the future you can say like, okay, I want to execute in DuckDB, in Polars, in whatever, and you can write your code in whatever you want. I think that would be the ideal state.
Yeah, the reason why I was asking is because I was quite a heavy Spark user, and like, you have two options there, right? The dataframe API, or you can go like from Python side, right? Or you can go for SQL. And I tend to write, SQL at start, but then to test everything, and then ensure that everything is the way in the same way written, after the changes, it's super hard, right? And like when Ritchie mentioned, like the software development practices, right? So you can write tests, on smaller bits and pieces, instead of running some smaller subqueries from time to time, right? Checking them, joining them again, and so on. So like what I really resonate with what Rich mentioned.
Yeah, I think it's even on the Polar side a bit more interesting, because we can run SQL on a lazy frame, and lazy frame is already a DAG resulting from some data frame API. So you do some data frame operations, you get a lazy frame, and on that you can run SQL again. Now I'm not sure if we can then continue again with the data frame API, and maybe we can then. I'm not sure how long we can do this. I haven't tried this because this is all relatively young, but I believe we can at least mix and match SQL and a data frame API a little bit. So I think it opens up some ways for meta programming. I am not really sure this is something I would encourage, though. Um, mm, this is it's very young on our side, so I have no opinion on this yet. If this is something you should do, but it's at least possible.
Yeah, but from other end, it's like very programmable, right? In
Yeah.
SQL, you cannot actually, write a loop, to actually call the columns, right? You have to
Yeah.
predefine them and then inject in the SQL itself, right?
Yeah.
Dataframe API, you can, loop it in the
Yeah.
lazy one and just couple everything.
Yeah, I think that's already possible. So if you can write a SQL query on a Polar's lazy frame, and that results in another lazy frame, and you will know what you can loop over the columns of that, for instance. So yeah, you can do, I would call it meta programming, like combine SQL with this DAG, which the lazy frame is, with a schema. It's a promise of computation, which also has information which you can get out and make new decisions upon. So you can write logic that uses that information to modify the DAG again. So yeah, I think there's cool possibilities, which opens up really strange things. For instance, one example is I heard of a user who uses Polars to do finite element computations. I don't know if you're familiar with that. Finite element computations are really complicated computations needed for physics, and they programmed their states in a data frame and they did like 700 joins. And they didn't write them out themselves. No, they write them out with Python. So they write out the query, the Polars query, which I call metaprogramming, and you get those huge, insane DAGs. But it all works, and it's because we're so fast that it's worth the overhead of doing this for them. But yeah, you get exotic things, I think.
Yeah, talking about exotic things, Mark, do you know any examples, where pandas were used in, some interesting ways?
And we ran a poll a few years ago, and yeah, I think pandas is used in any possible way. I think pandas is pretty big, like for good and for bad. I think the last time I checked, we had something like 2 million unique visitors in our website per month. So yeah, I don't know. I know the ones that I use. I don't know anything that's super fancy, but yeah, I imagine that literally everything. For example, we have some grants because pandas is used in biology. That it's something that I was kind of surprised. I was not like expecting directly like to be applications on biology. Also, when a few years ago, I think it was 3-4 years ago, there was this black hole image, the first black hole image published. Like the researchers like cited pandas as one of the tools they were using. So it's again like, oh wow, really? They're using pandas for that. So I think we have like plenty of use cases, and yeah, I think like being a generic library that you literally kind of like somehow a spreadsheet on steroids is like, I would guess like Excel is also used in any possible way.
Yeah, it's probably just like Excel everywhere.
Yeah, but that kind of makes sense, right? When the tool is for that long, right? People like adapt to it, right, and find different ways, to suit their needs, right? So that actually makes sense. So I'm gonna move a bit forward, with this, and now, turn to the public, for the questions. If someone has some for Mark or Ritchie, so please raise your hand.
So the arrow was mentioned so many times that it seems to be like everyone is going to use this. Is this like solid trend, or after a few years we will see a switch to another technology or something else gonna happen?
Yeah, that's a very good question. To give a bit of context, like pandas, probably you know about that, was created I think like 15 years ago by Wes McKinney. Wes McKinney has not been involved in the project for a long time, and one of the reasons is, well, he moved a bit, like did some other stuff, but for many years now he's been working on Arrow. He's one of the founders of Arrow. So he literally see all the problems that pandas was having and saw that pandas itself couldn't solve those. And actually it didn't make sense to pandas create like a great in-memory representation and that, like ignoring the rest of the community, because Arrow is pretty much like internal for the user, let's say, the experience for the user is very different, whether you're using R or Python or PySpark or Julia or many other things. Internally, it's pretty much the same. Like what's going on under the hood is pretty much the same. You're saying like, okay, I have some data in memory, I have this column, and I want to add one to this whole column. And it doesn't really matter what you are, how you're expressing it. If it's SQL, if it's Julia, it's Python, and that. So finding this need, basically, like Wes McKinney with other people coming from, I think some from R and I guess from other backgrounds, they started Apache Arrow. That's why the Arrow adoption is pretty big, because it was designed for the whole community in mind, saying like, okay, you have a data frame, and data frame is this definition of like a table where every column has the same type. It's like somehow the same concept. And when you have this and you want to have it in memory, basically there is no reason why every library should have their own representation, because there should be representation. That being said, I think like Arrow is surely not perfect, like as not all it is. It's kind of new, it's few years old, and I assume like in the future we'll have something probably like an improvement on Arrow, probably coming from Arrow itself, from the project itself, because as far as I know, the management of Arrow is pretty wide and representing different point of views. But then DuckDB, for example, I know that they don't fully agree with Arrow. It's making them slow in some things, so they decided to change few things. So DuckDB internally, when it's having data in memory, it's basically having Arrow, but with whatever they need to change. So it's not exactly Arrow. They can convert to Arrow pretty quickly, and I think Polars also had some change, right? I think you mentioned like Ritchie. So yeah, I think we'll see more of these. Also, it doesn't express all the use cases. For example, if you have like very sparse data, you have like more missing values than values. Arrow is not very efficient because it will still allocate memory for all your missing values, which is not super efficient. So yeah, you will have like different, like let's say, conflicts in the Arrow, trying to push different directions. Hopefully, like the whole Arrow, it becomes like, or whatever it's Arrow or a continuation of Arrow, it becomes like this standard that everybody uses, because if everybody is using like the same representation, and if that makes sense because all the tools are using more or less the same, are doing the same things, I think that's a very positive thing, because literally you can take a pandas data frame and immediately at the next line say 2 polars, nothing happened internally, the data is still the same, no conversion has been made, and you can continue working on polars or the other way around.
Yeah, so I want to add a little bit on how this actually works. It means that the data is somewhere on the heap, and we can just say, okay, this is an arrow pointer, it represents this data type. You can read it as this data type, and this is the length, and it works. We only need to read a pointer, and we have loaded that data, so there's no copying of data. And within a process, it means that every tool that knows how to read or write Arrow can share the same memory, which is, of course, super efficient. I think this is also the reason why, one of the reasons why Arrow was designed was the realization that in Cloudera, I believe it was, that most of the compute went into serialization, deserialization. So you go from one tool to another tool, and you have your memory in a specific representation. For instance, pickling. You would pickle, send it over the wire, and then you would depickle again. And that's because the way the memory is represented over the wire is different than how you would represent it in memory. And in Arrow, it's actually the same. Also, there's also another thing. If we want to save Arrow on disk, we can store it on disk the same way we store it in memory. So we could send Arrow over the wire to another process, which would not be zero copy, but because it's the same representation as we send it over the wire as we have it in memory, there's no serialization and deserialization cost, no overhead on that.
Anyone else? So then I'm gonna ask my question. It's like, since I saw the transformations, or like the syntax on polars is in some cases very similar to Spark, in some cases it's very similar to pandas. So what was your inspiration on some namings, or like in a situation? Was it Rust-based, or
explicitness. Explicitness and declarativeness. So if you read a query, you should understand what we're doing. There shouldn't be no magic. Though it can be a little bit more verbose with writing, code is written way more often than that it's a read way more often than that is written. And we can autocomplete. We hit the tab and the longer name just walks out. So it should be declarative and explicit. That was the inspiration, and it looks very similar to Spark. That's because if you want to represent a column, the col is a natural name. It's short. So that's why it's similar. But the expression engine in Polars is a bit more exotic, or not. Yeah, it's more rich than it is in PySpark, I believe. We can do a lot with expressions. They were super powerful, but yeah, explicitness. We took inspirations, but we didn't want to copy.
Like my guess here was, like easier for all of the sites to adopt, right? The similarity from pandas, can easier, attract, more pandas users, right? And from the Spark side, right, you can also add them there as well.
Yeah, that was not the reason. We started with the pandas API. Initially, we wanted to follow the pandas API, but it became really hard to understand what the user intent was with the pandas API. There are a lot of lambdas, for instance, which are a black box for on our side. Like, okay, what does the user want to do with this lambda? We're not going to run it. So it's hard to translate the pandas API into a query plan where you completely understand, oh, this is what you mean. So if you were able to do this, you would need to be rather conservative in optimization. So I wanted to have this explicit. I also didn't want any, I had some functional programming influences. It should be explicit and pure. Like the input, the only data comes from the input in an expression, not from somewhere else, not some hidden state. That's, for instance, why I chose not to have an index, because not the index in the way pandas has it, because I often read pandas queries and the result could be different depending on the state of the index, which felt implicit to me. It's not super clear if I read this query how it will behave, and that was the reason. That was the design decisions.
Okay. And final question in regards to polars before we wrap up is, will there be an option for user-specific, like type hinting, like hinting for some optimizations? It's going to be only handled, on the polars engine in general, always.
What do you mean with hinting on types?
So not types, but in general, like hinting, right? Let's say in Spark, right? If you write a query, like SQL query, right?
Right.
You can specify, like let's try broadcast join, right? That's one thing, right? Or pass some setting which would turn on something on and off. So will it be like kind of a like actually query engine which is where everything is taken care of for the user, or it will allow some like manual tweaks?
We're trying to, as long as you write your query explicit and we understand what you're doing, we hope that we can make the proper optimization decisions. So be explicit, and often idiomatic polars is the fastest polars. The thing like those join hints, we currently don't do this, but there are, for instance, realizations that if I sort my data first, polars can use a sorted fast path, and this can actually be faster. So there are still things in which you can influence performance with these kinds of tricks, which I don't hope you would do that much. I hope you write your query as you intended, and hopefully we can make this as fast as possible. That's the way I hope we can do it. I want readable, clear queries. Yeah.
Okay. And like the final question, so what would be your advice for the dataframe users?
As general or
In general.
in general? Pooh. Do you have one?
Well, I don't know if I'm understanding the question in the same way, but yeah, if you're thinking about like whether they should use pandas or polars, I think that's one of the things that they might be guessing. Many people might be guessing. I've seen this question like being asked several times on the internet. Yeah, I think like Polars is amazing. I think it managed to learn not only from the mistakes of pandas, but also from like all the database theory. It's built like as a database expressed as a data frame. I think that's very different from pandas. Pandas history, besides being like a pretty old project, is like 15-year-old. It was designed as a tool for finance mainly. Pandas, not many people knows, but the name pandas doesn't, well, it's a playing with words, but it comes from panel data. It's no more than the animals, and panel data is something that was deprecated like many years ago, that it was a three-dimensional structure. So the whole concept of pandas, the indexing, is something that many people in the core team, I would say, like including myself, I would question. I don't know if I would immediately remove it, but it's something that if we had to start from the beginning, the same as the API, I fully agree. And I think that's controversial for what I said. Like, there are different users, and different users have different needs. And I think some users love the Pandas API. I think if you're not that much of a person with software engineering background, I think like you tend to love it more. You have use dev object, and you know that you get like thousands of things that you can call on it, and makes your life pretty easy. If you're from software engineering, it's pretty annoying. I think it's like it has many different things. Also the naming, it's a bit like, not sure if it's come more from the financial background, and Pandas is not in a position that now it's gonna change much, because the users, we assume that they prefer the stability. Like, so many people have been teaching about Pandas, learning about Pandas, and if we start changing everything at every version, it would be like a very poor job that we'll be doing for our users. So I think in this sense, I think like it depends on the user. Like, I think like for data frame users, if you are thinking what you should be using, like, I think it's not only pandas or polars. I think there are very good use cases also for DuckDB and things like distributed or whatever. It's like luckily many more options than those. But yeah, it's like focusing on your needs. It's like, don't try to find like this is a war. Actually, I hope we collaborate more with polars. I'm super excited that there is an alternative. I think like pandas being the monopoly, it was a pretty bad thing. I think it was a great thing, because pandas for many years was even in risk of disappearing. It was like 3 people running the whole show, like until when I joined the project, like few other people joined at that time, but it was mainly 3 people doing like an insane amount of job, because the project was huge, the maintenance was super hard, and it was like very little resources on that. And so a few people like including myself jumped at that time. So I think like having pandas is an extremely good thing. I think like we kind of take it for granted, and many people criticize. But I think it's super good that we had it until now. I think it's super good that now there are alternatives. I think pandas is gonna stay for the long term. I think like I don't see pandas going, even if polars and many other tools are much better in many ways. I think like if you are starting a big project and you want API stability, you want something tested by millions of users, yeah, use pandas, I would say, probably. If you are gonna say like, okay, I'm starting, it's my own project, I'm happy to rewrite few things when they are changing the Polars API, and I want the speed, and I want something that might be a bit better design and nicer to work with, I would totally go for Polars myself. Unfortunately, I didn't have the chance. I worked too much on like on the other side of pandas, not that much on the data science part, but yeah, I surely would like to use pandas for some of the projects, like eventually myself.
So to sum up, choose the right tool for the job. Actually, don't go chasing fads, and choose whatever works best for you.
Yeah, that's the boring answer.
Okay, cool. So thank you for speaking with me. It was a pleasure, to talk with you guys about polars and pandas, and hopefully for the audience, it was nice to hear these things as well. And have a nice day.
Thank you.
Thanks.